Hello friends, today's question. A hemispherical bowl of radius r 0.1 meter is rotating about its own axis, which is vertical, with an angular velocity omega. A particle of mass 10 to the power minus 2 kg on a frictionless inner surface of the bowl is also rotating with the same omega. The particle is a height of h from the bottom of the bowl. Obtain the relationship between h and omega. What is the minimum value of omega needed in order to have a non-zero value of h? In the B part, it is desired to measure g, that is acceleration of gravity, using the setup by measuring h accurately. Assuming that r and w are known precisely and that the least count of measurement of h is 10 to the power minus 4 meter, what is the minimum possible error delta g in the measured value of in the value of g? First of all, let's draw the diagram. So a hemispherical bowl is given. So let us draw this hemispherical bowl like this. And this is its axis of rotation. Suppose it is rotating in this direction. And it is given that there is a particle of mass. Suppose this is a particle and its height is given at h from the bottom. From the bottom of the bowl, this is height h. The radius of the bowl is given as capital R. So this will be coming as R minus h. Okay. So because of the normal force between the mass and the bowl will be acting in this direction, n, and this n can be divided into two components. In this direction, that will be n sine of theta, and in this direction it will be n cos of theta with this angle of theta. And let us suppose this is the r distance. So on the object there will be another force which will be acting in downward direction, that is mg. So we can say that mg will be equal to n cos theta, n cos of theta will be equal to mg, that is equation 1. And equation 2, the n sine theta will be providing the necessary centripetal force. So we can say that our n sine theta will be equal to mr omega square. This is equation number 2. So we divide equation 2 by equation 1. Equation 2 divided by equation 1. We get this as tangent of theta is equal to r omega square by g. Okay. And also from the figure we can say that our tan of theta will be equal to r divided by r minus h. R minus h. So if we equate these two, we get r omega square divided by g is equal to r upon r minus h, and r cancel out with r. Okay. You can just show this one like this. So this is angle theta, this is of r, small r rather, and this is capital R, and this is our r minus h. So tan theta will be equal to this value. So from here we can say our omega square is equal to g r minus h. So this is the relationship between H and W. This is the relation between H and omega rather. And now we are going to find out the minimum value of omega. So if you modify this equation, we can write this as R minus H is equal to G upon omega square, and from here we can say our H is equal to R minus G upon omega square. And it is said that in order to have a H should be having a non-zero value. You can say but, or you can say for H to have a non-zero value, H should be greater than 0. So from here I can say R minus G upon omega square should be also greater than 0. And this gives us that R should be greater than G upon omega square, or we can say omega is greater than square root of G upon R, and we are supposed to find out the minimum value. Okay. Therefore the minimum value of that is given as angular velocity is equal to omega minimum. So we get omega minimum is equal to square root of G upon R. This is the minimum value of omega, so that H is non-zero. This is the minimum value of omega, so that the value of H is non-zero. Now in the B part, okay, we need to calculate it. So let's put the values. So we get omega minimum is equal to 9.8 and radius is given as 0.1. So we get as omega minimum is equal to 9.89 radian per second. And we are supposed to find out the minimum possible error in the measurement of delta G. So we already know that H is equal to R minus G upon omega square. Okay. So we need to find out change in delta G. Okay. You can say change in G, this can be written as delta H is equal to 0 minus delta G upon omega square, and from here we can say delta G is equal to minus H upon multiplied by omega square, and the minimum least count is given as 10 raised to minus 4, so minus 4 into 9.8 and 9 square. So we get delta G is equal to 97.87 into 10 raised to power minus 4 meter per second square. So this is the minimum possible error. You can say this is the minimum possible error in the measured value of G. In the measured value of G. This completes the question. Thank you.